If asked to point exactly where a bird's nose is, you might hesitate. Looking closely, there isn't an obvious snout or a button nose. Because their faces are dominated by hard, unyielding beaks, we often assume they lack the olfactory organs found in mammals. However, birds do possess nostrils. They are often hidden in plain sight, camouflaged against the texture and color of the bill. For the majority of species, these small openings are situated right on top of the upper beak. Nature provides variations based on environmental needs. Some birds feature nostrils positioned further down the length of the bill, while others have breathing holes concealed inside their mouth structures. This anatomical structure serves as a sensory gateway, connecting the bird to the chemical signals present in the world around them. Like all terrestrial animals, birds must continuously draw in air, and these small beak openings act as their primary intake valves. Every breath drawn through those holes carries microscopic chemical signals from the environment directly into their respiratory and olfactory systems. This continuous airflow confirms that birds are actively sampling the chemical makeup of their surroundings. Out on the open ocean, food sources are sparse and visually microscopic against millions of square miles of rolling waves. The albatross navigates this wilderness with ease, spending months on the wing without ever touching land. Finding a meal like a floating squid in this vast expanse using only eyesight is a statistical improbability. When the sun sets, hunting becomes even more difficult as vision is neutralized by the darkness. Success in this environment requires a tracking system that operates independently of light and physical landmarks. This albatross head profile demonstrates the specific evolutionary adaptation that defines the group known as the tube noses. These prominent tubular structures sit directly on top of the upper beak. These tubes capture and concentrate marine odors, acting as high-sensitivity scent tunnels as the bird flies. Once the bird follows the scent to its target, the large hooked beak is used to secure the catch. This equipment allows the albatross to detect the smell of floating food sources from miles away. Because the system tracks chemical trails, it enables the bird to hunt effectively in pitch black. The albatross beak functions as a long-range chemical radar system, essential for its survival at sea. In terrestrial habitats like forests and wetlands, the biological requirements for survival change. The avian sense of smell exists on a broad spectrum, dictated by the specific needs of each species. While the albatross occupies the high end of this scale, many common birds sit at the bottom, possessing a sense of smell that is virtually useless. These species survived by prioritizing other senses instead, such as razor-sharp vision or acute hearing. Nature only invests in specialized olfactory tools if a creature's specific habitat demands them. Looking beyond birds to the rest of the animal kingdom reveals a broader pattern. For the vast majority of animals, olfaction is a baseline requirement for existence. Scent is used to detect hidden predators, navigate terrain, and locate food sources that are otherwise invisible. The albatross thrives in some of the world's most unforgiving environments by relying on its specialized sensory anatomy to navigate and hunt. Birds have noses, and in these extreme environments, those nostrils are critical for their survival.